In the next couple of sections, we're adding and subtracting with fractions. Then for these sections, we're going to need common denominators. In the first few sections of chapter 2, we were just multiplying or reducing or dividing fractions. You don't need common denominators for that. You'll see written on the top of the page here that 2.3, section 2.3, I deleted it. I wrote section 2.3 with the idea it was going to make adding and subtracting easier to explain. And I just kind of overthought things, and it actually made it harder. So we're just going to jump into section 2.4. The first 14 problems just get us used to adding or subtracting fractions that have the same denominator. These are easier. And I'll just jump in. Problem 2 is an addition problem of fractions that both have a common denominator of 10. When we're adding fractions, we just add the numbers in the numerator, leave the denominator unchanged. In order to add fractions, you have to have the same denominator. If the denominator isn't the same, you need to do some work to make the denominator the same. So these two fractions are reduced to 5/10, or add to 5/10, and that would reduce to 1/2. Always after I add or subtract a fraction, I should see if it can reduce. We get to the variable part, the rules for reducing are going to be the same as the rules in 2.1 and 2.2. Problem 4 is a subtraction problem, and I could do the same. The denominators are the same. I could write the two fractions as 1. I might put the second negative number in a parentheses just to make the negative sign stand out. Regardless of if I show this step or not, the double negative is going to turn to positive. And I should get 7/5 for my answer, which is 1.4 or 1 2/5. I prefer improper fractions for my answers. That fraction doesn't reduce. So sometimes when you add a fraction or subtract a fraction, you can reduce to get a final answer, and other times you can't. 6, 8, 10, 12, and 14, I think, are all going to reduce. And there's not really a trick for 6, so I'll just jump into it. For 6, I'm adding fractions that have the same denominator. So I can make the two fractions into one by simply writing the numerators together in a single fraction. When I'm dealing with variables, after I make the two fractions into one, I need to combine like terms. And in the numerator here, there's definitely not like terms. The negative 18 plus 6 can be combined to a negative 12. If I stopped here, this would be like stopping at 5/10 for problem 2, because this fraction is actually reducible. This now is like a section 2.1 problem. Once I get the like terms combined in the numerator, I should see if I could factor, and if that factor might lead to some canceling. And that's going to be the case for the next few problems. The problems that start with common denominators, it's easy to make them factor and cancel. Once we get out of the group of problems that have common denominators, not many of the problems are going to factor and cancel. So in problem 6, the a-3's can cancel after I factor and cancel. I've canceled the entire denominator. Technically, everything turns into 1. I'm left with a 4 in the numerator, a 1 in the denominator. I wouldn't write a fraction with a 1 in the denominator, so I'm just going to write 4 for my answer. The big trick that we have to be worried about as we go through this section is that when there's a subtraction in front of a fraction that has a binomial, you need to subtract both terms in the numerator, which means I need to subtract z and I need to subtract 17. When I make the two fractions with the common denominator in number 8 into a single fraction, I have to be super careful to subtract both terms in the right numerator. So I need to subtract z and I need to subtract 17. I'm not only subtracting the z, I'm also subtracting the 17. So the minus in the numerator in between the fractions distributes all the way across the right numerator. Now I'm going to combine like terms. In the numerator, I have 5z minus z, which is really 5z minus 1z. And that's going to combine to be 4z. So part of my numerator is going to have a 4z. My denominator, when I'm simplifying the numerator, is just going to tag along. And the plus 1 minus 17 are also like terms in the numerator. And plus 1 minus 17 give me a minus 16. So if I stopped here, this would be equivalent to stopping problem 2 at 5 over 10 because this is a reducible fraction. To reduce fractions when there's adding or subtracting in the numerators, you look for common factors or even two parentheses factoring. That numerator of 4z minus 16 has a common factor of 4 that I could factor out. And when I factor out that 4, I'm left with a z minus 4. Will cause the z minus 4's to cancel, just like the a minus 3's canceled above it, but I get the same answer because I've canceled the entire denominator. I don't need to write my answer as a fraction. I just need to write what's left in the numerator, and what's left in the numerator is just going to be 4. Eventually, we get to the problems that have unlike denominators, and they're a lot more work. For 10, I'm starting off with a subtraction problem and the denominators are the same. When I have a subtraction problem, it doesn't impact the numerator on the left, but it does the numerator on the right. I need to subtract both the x and I need to subtract the negative 3. So this is illustrating subtracting the x, subtracting the negative 3. Usually, rather than showing subtracting the negative 3, realizing there's going to be a double negative, usually when I have a subtraction, I just wind up changing the signs. So let me do that now. I'm going to make the numerator 2x minus 5. I'm going to sneak a 1 in front of this x, and the double negative when I subtracted negative 3, I'm going to make a positive. Now in the numerator, I'm going to go 2x minus 1x. That's going to give me a 1x. I'm not going to write the 1 anymore. And I have minus 5 plus 3, which are like terms. Those have opposite signs. And those are going to combine to be a minus 2. If I did minus 5 plus 3, I get a minus 2. So this is going to be more typical what happens when we get into the bottom group of problems. That I'm going to combine the two problems and neither the numerator nor the denominator will be factorable, and the fraction won't reduce. This is kind of mostly once we get beyond the first 14 problems what's going to happen. That would be the answer for 10. That fraction doesn't reduce. You can't cancel an x minus 2 with anything but an x minus 2. For 12, I'm going to make the two fractions into 1. I'm going to leave the x squared from the left numerator, write it before the minus 9 in the right numerator. The denominator doesn't change. You have to have common denominators when you're adding or subtracting, but they don't change when you add or subtract. I'm going to factor the x squared minus 9 by realizing it's a difference of squares. I'm going to square root the 9, divide the exponent of 2 by 2, and I'm going to fill up my parentheses. I'm going to lead them off with x's and end them off with 3's, and switch the signs. And now I'm going to cancel the entire denominator, so I don't need to write a fraction anymore. And I don't need the parentheses in the numerator anymore because I've gotten rid of all the factoring, and my entire answer is just that x minus 3. 14's more or less the same. There's a variation of these problems that I can't remember right now that I should be putting in here, but for now I'll leave this like this. Maybe I'll add something a little bit later and update this video. In 14, it's an addition problem. When I make the two fractions into 1, I don't need to change any signs. I'm going to factor the numerator in 14. I know when I go to factor that numerators, I'm looking for numbers that multiply to negative 4, add but really subtract to 3, and that's going to be 4 and negative 1. I'm going to sight factor that numerator, and the numbers that are going to be useful are 4 and negative 1, because if you multiply them, you get negative 4. If you add them, it's really subtracting and you get 3. So when I sight factor that numerator, I'm going to get a plus 4 and a minus 1. And just like the problem above it, the denominator is going to cancel. won't need to leave a parentheses in my answer. I won't need to write a fraction in my answer because the denominator's gone. That's the friendly 10 minutes of this lecture. And then we have about another 50 or 60 minutes, hopefully not more, of non-friendly, where we have uncommon denominators. And in order to add or subtract when you don't have the same denominators, you need to make the denominators the same. Our problems pair up pretty nicely, so I'm going to start with 16. 16 doesn't have the same denominator because the fraction on the right has more y's than the fraction on the left. If I look at the two fractions and I expand the denominator, both denominators have a yz, but the second denominator has an extra y. What I'm going to do is make the fractions have the same denominator. I'm going to work on that left fraction, and I'm going to make it have two y's in the denominator. When we're dealing with adding fractions, if I do something to the denominator of a fraction, if I multiply the denominator of a fraction by anything, I need to multiply the numerator by that fraction by the same factor. And when I do it, I like to be efficient. I multiplied by y on the left in the denominator because it matches up the right fraction. I'm going to multiply by y on the right in the numerator because that's where I'd like to see the y. So what I've created now is two fractions. This equals the line above it, so I should put equals. The first fraction is 7y over y squared times z. The second fraction is 6 over y squared times z. So now I have the same denominators. I'm allowed to add the fractions. I can't add the fractions until they have the same denominators. And if I reduce right now, I'm going to go back to the original problem. So we're not going to reduce after we create the common denominators until we get the two fractions made into one, and then maybe they reduce. So I've got the denominator right. I'm going to write the terms in the numerators next to each other. And the plus sign between the 7y plus 6 makes it so I could only cancel if there was a 7y plus 6 in the denominator. So if I was able to factor, maybe I could cancel. If there was a common factor of y in the numerator and I could get a y in front of a parentheses, then I could cancel one of the y's in the denominator. But there isn't a common factor of y in the numerator, so I can't cancel the y's. In order to cancel with the y in the denominator, I'd need a y in front of a parentheses, which I don't have. So this is non-reducible. Most of the answers in problems 15 through 32 in this section bleeds on into the 40s. I think it's like 44 or maybe 50. Most of the problems aren't going to be simplifiable once we get the two fractions into one. If I look at 18, I have 5 over 6xy for the left fraction minus 2y over 9x for the right fraction. Immediately I realize that this 6 and that 9 need to be the same number, and 18 is the least common multiple between 6 and 9. I could multiply 6 by 3 and get 18. I could multiply 9 by 2 and get 18. So I'm going to start off and do that. I'm going to make the 6 in the left denominator and 18 by multiplying it by 3. And if I multiply the denominator of a fraction by a number, I have to multiply the numerator of that fraction by the same number. Similarly, I'm going to multiply the 2 in the denominator of the right fraction, that is separated by this minus sign that I can't see anymore, by 2. I need to do it to the numerator. The first fraction has an x in the denominator as well as the second. Those match up. I don't need to worry about those. But the first fraction has a y in the denominator. The second fraction doesn't. I need to give that second fraction a y in the denominator. And if I give it something in the denominator, I have to match up in the numerator. I have to keep balance between my fractions. Now let me multiply some stuff out here. In the numerators, I'm going to multiply the 3 and the 5. I should write equals because this is equal to the line above it. In the numerators, I multiply the 3 and 5 and get 15. In the denominator, I was thinking 18. I get 18xy. After the minus sign, I multiply the 2's and I multiply the y's, I get minus 4y squared. And in the denominator, I multiply the 2 and the 9 and get 18, and I have 18xy. Now the two fractions have the same denominator, can write the numerators next to each other. This is going to be an adequate answer, maybe not the best answer. In order to cancel, I would have to have a parentheses and something in front of the parentheses that could cancel with an 18, like a 2. Something in the front of the parentheses that would cancel with an x or a y in order to cancel. If I don't get a parentheses with a single term in front of it, then I can't cancel the 18 nor the x or nor the y. The numerator doesn't really factor. Maybe it's not written the nicest. If I want to, I can rewrite the numerator with the negative 4y squared first and the plus 15 second, and then I can factor out a negative 1 and make it negative 1 times 4y squared minus 15. That almost looks like a square with a minus, but 15 doesn't have a nice square root. It's a decimal square root, so it doesn't this 4y squared minus 15 doesn't cancel. I can't reduce the 18xy because there'd have to be something in front of a parentheses that reduces with it. And I can't factor any further. I'd probably leave my answer like this. It doesn't really bug me if a polynomial is written in a bad order. I'm just kind of used to it. As I look at our problems, I feel like 19 is a little bit different than 20. So I'm going to work through 19 with you and see what happens. This 8 minus w being written in the bad order, that's the thing that's bugging me right now. But I'm going to leave it alone for a second. Usually having something written in a bad order, unless I'm factoring it, doesn't impact. If I'm factoring and canceling, it makes a big deal. But when I'm adding or subtracting, the bad order is not such a big deal. To get started on your 19, the only thing that can factor is this 2w minus 6. That 2w minus 6, I can factor out a common factor of a 2. So I'll do that. The right denominator doesn't factor at all. I want my denominators to look identical, and they have a w minus 3 in common. The left one has a parentheses, the right one doesn't. Let me give the right one a parentheses. Now the denominators look more alike, but they're not exactly alike. The right denominator is missing the 2 that the left denominator has, so I'm going to give it that 2, top and bottom. And now I'm about to make the two fractions into 1 because they have the same denominator. Should write equals because of what I've written is equal to the line above it. I'm going to work horizontally here because I have more room horizontally. I'm going to write my numerators together. The left numerator of 2w minus 1. The right numerator of net minus 2 times 8 minus w. I'm going to write over the common denominator. Once I get the two fractions combined, then I can start cleaning up the numerator. That numerator, I need to go minus 2 times 8 and minus 2 times minus w. So minus 2 times 8 and minus 2 times minus w to clean up the parentheses that I have in that numerator. So let me write equals because what I'm writing is equal to the line that I just worked. Minus 2 times minus 8 is minus 16. Minus 2 times minus w is plus 2w. And I'm over 2 times w minus 3. If I get a number in front of a parentheses like a 6, I could cancel this 2. If I get a factor of w minus 3, I can factor that w minus 3. In the numerator, I have common terms. I have a 2w plus a 2w, and I have a minus 1 minus 16. The 2w and 2w add up to 4w. The minus 1 and minus 16 add up to a minus 17. So the numerator is going to simplify to 4w minus 17. And I'm not doing any work to the denominator at this point. Most of the problems between 15 and 44, I think, don't have any factoring and canceling that can be done. the 2 can only factor if there was a parentheses in the numerator and an even number in front of the parentheses. The 4w minus 17 can only cancel if there was a 4w minus 17 in the denominator, which there's not. That's as far as I can go for 19. I think 21 and 22 look similar enough that I'm not going to do 21, I'll do 22. I'm going to factor both denominators. So in 22, both denominators are factorable. If I factor the denominators, it makes it easier to get the common denominator, keeps this common denominator smaller. The denominator on the left, there's a common factor of a 3. So I'm going to write a single parentheses and factor out a 3 and be left with a y minus 7. The denominator on the right, I'm going to factor out the common factor of 4 and be left with a y minus 7. Now I look at the denominators, I want them to be identical. The y minus 7s aren't keeping them different, but the 3 and the 4 aren't the same. I'm going to turn the 3 and the 4 in front of the parentheses into 12s. I'm going to multiply the left fraction by 4 over 4 to get a 12 in front of the parentheses in the denominator. I'm going to sneak a parentheses in the numerator to properly simplify. And the right denominator, I'm going to multiply, or the right fraction, I'm going to multiply by 3 over 3. I'm going to sneak the parentheses around the numerator. So what I've created is this. I have 4 times 6y plus 1 over 12 times y minus 7 plus 3 times 2y minus 1 over 12 times y minus 7. I have common denominators. I can make the two fractions into 1. Because this is an addition problem, I don't have to be as careful when I make the two fractions into 1, but I will be careful here, even though I don't have to be quite so careful. So I'm going to make the two fractions into 1. I'm going to write the left numerator and the right numerator together in one fraction that has a single copy of the common denominator. Now I'm going to, in the numerator, clear the parentheses and combine like terms. The denominator I'm not going to change at all. So in the numerator, I'm going to go 4 times 6y for the first parentheses and get 24y. 4 times 1 and get positive 4. And then 3 times 2y and get positive 6y. 3 times minus 1 and get minus 3. And then I have the denominator 12 over y minus 7. In the numerator now, I'm going to add 24y plus 6y. Those are like terms. And I'm going to subtract 4 minus 3. This is going to give me 24y plus 6y is 30y. 4 minus 3 is plus 1. A 30y plus 1 can only cancel with a 30y plus 1. A 12 in front of a parentheses can only cancel with a number in front of a parentheses. And a y minus 7 can only cancel with a y minus 7. There's no canceling that can go on here, specifically because nothing is factorable, and I don't have identical 30y plus 1s or identical y minus 7s or numbers in front of parentheses that are cancelable. So for 22, this is going to be my answer. For 24, I want to go ahead and factor the m squared minus 16. And real quickly, if I try to factor m squared minus 16, it's a square with a minus. I'm going to divide the exponent by 2 on the letter and get an m. I'm going to square root the 16 and get 4. When I factor that, I should get two identical parentheses, one with a plus, one with a minus. And I can make my life a little bit easier if I write this in the order that's more helpful. Usually, if there's a common factor between the denominators, I want to write that first. The left denominator has an m minus 4. My factoring has an m minus 4. When I go to write the factoring, I should write the common piece first rather than the difference. So I'm going to, when I write the denominator factored, write the m minus 4 first and the m plus 4 second. So now I look at the fractions. They don't have a common denominator, but it should be obvious what the common denominator is because they have an m minus 4 in common. The right denominator has an m plus 4 that the left denominator doesn't. So I'm going to give it that m plus 4 top and bottom. So now I have two fractions with the same denominator. So I'm going to make the two fractions into one, and I need to subtract the m, and I need to subtract the negative 2 in the right fraction. When it's a subtraction problem, you have to be super careful. If the numerator to the right's a binomial, you can't just subtract the first term, you need to subtract them both. Should be writing equals because what I'm writing is equal to the line above it. Now I'm going to work on this numerator. I have 2m plus 8 when I clear the first parentheses. That minus m is really a minus 1m, and that double negative 2 I can write as a plus 2. I can't cancel unless I get a factor of m minus 4 or a factor of m plus 4 in the numerator. I'm going to work on my numerator. I'm going to combine the like terms of 2m minus 1m, and I'm going to get a 1m. I don't need to write the 1. And the plus 8 and the plus 2 give me a 10. So my numerator is going to be an m plus 10. There's no factoring that goes on there, and an m plus 10 can only cancel with an m plus 10. And the denominator in either order has both an m minus 4 and an m plus 4. Most of the problems when we have unlike denominators after I get the two fractions combined aren't going to cancel. It's hard to make them happen that they cancel. So 23 should be just like 24, structured exactly the same way. It's kind of my usual. I try to structure the odd and the even problems the same way. So 25 and 26 look a lot like each other. 26 looks harder than 25. Maybe it's going to make it hard to follow. So I'm going to do 25 with you rather than doing 26. If you want to, pause the video, try to do 25, and then watch me do what I do. So for 25, both denominators need to be factored. Both of them just have a common factor. The denominator on the left has a GCF of an x. The denominator on the right has a GCF of a 2. So I'm going to write an equal sign because what I'm writing is equal to the line above it. I'm going to factor out an x from the first denominator and be left with a 2x plus 3. I'm going to factor out a 2 from the second denominator and be left with a 2x plus 3. Because I can foresee what's going to happen, you'll see that I didn't put the 2 right up against the parentheses. This is just because I've done this for so many years and I can think ahead, and I can make my work easier to follow. Having the 2 butted up against the parentheses would be normal, but I realize I can see ahead what I'm going to need to do. The denominators have 2x plus 3's in common. The left denominator has an x, it's missing the 2. The left denominator is missing the 2, the right denominator is missing the x, I guess. So what I'm going to do to the left fraction is top and bottom, give it a 2. That will make it have the 2 that the right denominator has. And right fraction, top and bottom, in a convenient place, give it the x. Doesn't matter because multiplication's commutative. Where I put the up and downs, I just kind of put them where it's useful. So in this first fraction, I put them to the left. It felt useful. Here I could put it in the middle and to the right, just because now it looks normal to me. So now my left fraction is 10 over 2x times 2x plus 3. I can certainly cancel the 10 and the 2, but if you do, you won't be able to add because you can only add when the denominators are the same. If you cancel before you make the two fractions into one, then you won't have common denominators and you won't be able to combine. So now I have the two fractions with the same denominators. I'm going to write the numerators next to each other. And sometimes instead of writing the denominator down, I just write LCD, which means common denominator, because I want the numerator to be in a better order. I want the constant term last just because I'm used to that and it was easy to do. Don't have to do that. You could have left the numerator backwards. A 2x can only cancel with a factor in front of a parentheses. A 2x plus 3 can only cancel with a 2x plus 3. A 7x plus 10 can only cancel with a 7x plus 10. There's nothing in front of parentheses to cancel the 2x with. There's not a 2x plus 3 to cancel the 2x plus 3 with. So that's going to be the best answer for problem 25. 28 and 29 are bad problems. I'm going to do 28. It might be slightly different than 27, but for these problems, I'm going to need to, in your problem, you're going to need to write the second denominator with the x first. I'm going to need to write my first denominator with the y first. So I'm going to start off, and when I have flip-flopped x's and y's, sometimes that's not a bad deal. That should be negative y plus 2. But when you're trying to get common denominators, you definitely need these things in the same order. So I'm going to write 3y over, and I'm going to factor out a negative 1, over negative 1 times y minus 2 minus 6 minus 2y over y minus 2. The clever thing to do for me is to do this division right now. 3 over negative 1 is negative 3, and I could write negative 3y over y minus 2 minus 6 minus 2y over y minus 2. I might try to walk you through yours because your problem looks a little bit harder. Maybe I'll do it and pause the video. Now I have the two fractions with the same denominator. I'm going to go minus 3y minus 6 minus negative 2y. I need to subtract both terms in the right numerator over the common denominator of y minus 2. This is going to give me minus 3y minus 6 plus 2y over y minus 2. And I'm going to combine the minus 3y and plus 2y and get a minus y. This would give me minus y minus 6 over y minus 2. That's an acceptable answer. I'm going kind of fast because I'm antsy to do your problem. Neither one of these will make it on the test, but I'd like to show you. And now I'm going to factor out a negative 1 and get a y plus 6 over y minus 2. That was a little fast. Let me try to slow down a little and do your problem 27 just in case you're interested. For 27, I'm going to write the left denominator with the x first. And in the left denominator, I'm going to factor out a negative 1 and be left with an x minus 3. Just like I did here, I can divide the negative through the numerator, but that doesn't work so good. It turns out that the trick that's going to be necessary is this. If I have a fraction with a negative in the denominator, I can move that negative up to the numerator, and those fractions are going to equal each other. So this common factor of a negative 1, I'm going to bump it up to the numerator, but it needs to apply to the entire numerator. So the big trick for 27, which is good to see if you're going high in math, maybe not so good to see if you're not going very high in math. I'm going to rewrite the numerator with the negative 1 in front, and this double negative I'm going to make positive and get rid of the 1. This is an evil, evil, evil problem, and I'm starting to fade, obviously. I should have written of x minus 3 there. So what I'm going to change this to is 4x over x minus 3 plus 12 minus x. And once I get rid of the negative 1, I don't need the parentheses anymore, over x minus 3. Now I can make the two fractions into 1. I'm going to go 4x plus 12 minus, I'll emphasize 1x, over x minus 3. Now I'm going to go 4x minus 1x and combine like terms in the numerator and get 3x plus 12 over x minus 3. Ready to pause the video and write an answer. I'm going to pull out a common factor of 3 in the numerator and get an answer that's factored but not cancelable. A 3 in front of a parentheses can only factor with a number in front of a parentheses, and x plus 4 can only cancel with an x plus 4, and x minus 3 can only cancel with an x minus 3. Don't worry so much about 37 and 38. I sneak them in there just so you could see it. If you understand it and you're going high on to math, that's a really good thing. If you don't understand it, it's not the biggest deal. So let me pause this video.